Let's begin by recalling the statement of binomial theorem. A plus b the whole raised to n is equal to the summation of from k equal to 0 to n, nck a raised to n minus k into b raised to k. We know this theorem provides an efficient way to expand a binomial expression without going through the tedious process of what? Multiplying it. Rather than multiplying it n times, you just directly need to use this formula. Suppose if I want to find the fifth term in the expansion, I need to expand binomial expansion fully to find the fifth term. Do you think whether it is a tedious task? Yes, that is also one big task. So there arises a need for some particular term, a general term, which can provide simpler, concise solutions which are less prone to errors. Now, how can we reach at a general term from the binomial expansion? Again, look into the binomial expansion. What will be its first term? The first term is obtained by putting k is equal to 0. So we get nc0 a raised to n. Now what will be the second term? The second term is obtained by putting k is equal to 1, that is nc1 a raised to n minus 1 into b. Similarly, the third term is given by nc2 a raised to n minus 2, b raised to 2 and so on. If this repeats, what will be the r plus 1th term? On generalizing, we get r plus 1th term is equal to ncr a raised to n minus r, b raised to r. This r plus 1th term is also called by the name the general term of a binomial expansion, and it is denoted by tr plus 1, and therefore tr plus 1 is nothing but ncr a raised to n minus r into b raised to r, where the value of r changes from 0 to n. So if we know this general term, one can find any term in the binomial expansion, whether it is the 5th or the 7th term or even the 20th term. One important thing to note is that when referring to terms by their order, it is that first term t1 is the term when r is equal to 0. So when you find t1, you put r equal to 0. Similarly for t2, the second term, we put r equal to 1. It is a common mistake to assume that the first term t1 should have r equal to 1, but that is a complete mistake. This is incorrect, and we tend to define tr plus 1 rather than tr to reinforce this fact. So always remember that when you are finding the first term, r equal to 0. Next, we will find the middle term of a binomial expansion. First, we found out what is general term. Now, going to the middle term. The middle term of a binomial expansion depends on the index, the power. This n can be either what? Even or odd. First, consider n is even. When you consider n is even, then the number of terms is what? N plus 1, which is odd. Therefore, the middle term is given by the formula n by 2 plus 1th term. So, what is the middle term here? N by 2 plus 1th term. So, remember, this is the formula to find the middle term. For example, find the middle term of the expansion x plus 3y the whole raised to 4. In this example, n is equal to 4, which is even. And the middle term will be the 4 by 2 plus 1th term, that is the third term. So it means third term in the expansion gives you the middle term exactly. Here we are not finding the exact value. This is just to make you understand how to apply the formula to do it. So what did I do here? I just found out which term is going to give me the middle term. So which term is going to give the middle term? The third term. Now, what will be the case when n is odd? When n is odd, the number of terms is n and total number of terms will be n plus 1, that is even. That means we have two middle terms. So the two middle terms are given by the formula n plus 1 by 2th term, and the second one is n by 3 by 2th term. So this is how you find the middle term when the power or the index is an odd number. Let's see for an example. Find the middle term of the expansion x plus 3y the whole raised to 5. Here n is equal to 5. So we have a total of how many terms? We have a total of 6 terms. So the middle terms will be 5 by 1 plus 2th term, that is the third term, and 5 plus 3 by 2th term, that is a fourth term. Now, considering x plus 1 by x the whole raised to 2n, there is another binomial expansion, and when you consider that x is not equal to 0, the condition is also given there. Now, using the formula which we have learned now, can you find the middle term? Yes, I can. The 2n, the power here is an even number. 2n is always even because 2 into any number will give us an even number. So when the power is even, the number of terms will be odd. So the middle term will be 2n by 2 plus 1th term, that will be the n plus 1th term, right? Yes. And the general term formula is tr plus 1 is ncr a raised to n minus r, b raised to r. Here a is equal to x, b is equal to 1 by x, and n is equal to 2n, that is the number of terms, and Tn plus 1 will be 2n Cn x raised to n 1 by x raised to n, and that is nothing but 2n Cn, which is now a constant term. So here the middle term we found out, and that middle term has a specialty that it does not have any variables, or it is simply a constant term. Now let's solve one more problem for better understanding. That is, find the middle term in the expansion 3x minus 2x raised to 2 by 3 the whole raised to 8. So we have a binomial with index 8. So look here, n is 8, which is even. The middle term will be Tn by 2 plus 1 or T8 by 2 plus 1, which is nothing but T5. So the middle term will be the fifth term. So when the middle term is the fifth term, the general term formula Tr plus 1 is NCR a raised to n minus r b raised to r, and in this equation we have to substitute the values and solve. So when you substitute that, n is equal to 8, r is equal to 4, a is equal to 3x, and b is equal to 2x raised to 2 by 3. Now, putting all the values, we get T5 is equal to 8c4, 3x raised to 4 into 2x raised to 2 by 3 the whole raised to 4. And doing all the final calculation, you will be getting it as 90,720 x raised to 20 by 3. If you have any doubt, you can do the calculations also here and check. So far we have discussed about the binomial expansion, especially finding general term and the middle term. Learning binomial theorem has its own importance. It is used in the other areas of mathematics like statistics and probability also. We all know our economy is heavily dependent on statistical and probabilistic analysis. Now, let's have a quick recap of what all we have discussed till now.
Manorama Horizon. Learning made simple.